morning, student. Today our topic is flip-flop, and flip-flop is not one of the sequential circuit. And why we are using flip-flop? Flip-flop is a single bit storing device. Further, it is further classified in SR flip-flop, D flip-flop, JK flip-flop and T flip-flop. Now first one is your SR flip-flop. It is set reset flip-flop. Again, if we are talking about flip-flop, here we can see this is clock. This is a major part of this which separate the sequential circuit from the combination circuit. In clock pulse we have like this. If flip-flop is triggered, or you can say gives its output at this level, up level, so it is called high level triggering, and at the lower side it is low level triggering. Suppose we are using in this flip-flop high level triggering. If there is no clock pulse, then it is not work, means your output is no change. Suppose we have previous output 0 1, then its output is 0 1. Again, if we are applying clock pulse and your SR is 0 0, then output is again no change. Qn minus 1 or Qn minus 1 bar, no change. Now, if your SR is 0 and 1, then output is 0 and 1. This is called reset condition, or status is called reset. If SR is 1 0, then output is 1 0. It is set condition. And last one is 1 1, means it's an invalid state. If we are applying 1 1 and flow this data, we can't have a fixed output, so it is called invalid state. Now if we are talking about waveform, now it is high level triggering flip-flop. Now suppose your S is watch, and R is now what is your output? Qn. Now it is triggered at high level, means here we can see it's a 0 0, then your output is previous, suppose previous output is 0, then for this clock pulse your output is 0. Now at this level your input is S value is 1 and R is 0. S is 1, then our output is 1. Now for next clock pulse our output is 1, right? Now here we have 0 1, then output is again 0 and 1. So Qn value is 0 for the next pulse, and here we have 1 0. 1 0 means your set condition, your output is again 1, right? This is about waveform. And again Qn bar. Qn bar is just opposite of this. Here you have 0, then 1. Here you have 1, then here 0. Here you have 1, then Qn bar is, this is 0, then this is 1. Again here you have 1, then it is 0. Then this is about the waveform of SR flip-flop. Now next one is D flip-flop. D flip-flop is a data flip-flop. Here in SR flip-flop we have two input and output is set or reset in case of 0 1 and 1 0. Means your input is reverse both. So in D flip-flop we are using one input by changing this. Here we are applying a NOT gate. If we are applying 1, then it's 1 and 0. If we are applying 0, then it's 0 and 1. Now, what about the characteristics table? Clock D, Q, right? If there is no clock pulse, then no change. Now clock pulse and we have 0, means here we are applying 0 and 1, then our output is 0 1. If it is 1, then it's 1 and it's 0, means it's 1 and 0. Again this is reset and this is set, right? Now what about the waveform? Okay, fine. Say this is D flip-flop, right? Triggered at high level. Now here output Q1 is what? If D value is 0, Q1 is 0. Okay, here your D value is 1, then Q1 is also 1. For this clock pulse, this value is 1. Now here D value is 0, then Q1 is 0. At this point your input is 1, then its value is also 1, right? And for Q1 bar, just opposite of this, 1 0 1 and 0, right? This is about the data flip-flop, or you can say D flip-flop. Thank you.